So, as we said at the end of the introductory part, we need to consider the limit as theta tends to 0 of 1 minus cos theta divided by theta. And the problem with this limit is that as theta tends to 0, both the numerator and the denominator tend to 0. And that means we need to do some more analysis to try and see what happens in this limit. Now, the first part is a trick. And if you don't know the trick, you wouldn't really know to use it. And that's probably why you're unlikely to get a question about this. But what we do is we multiply top and bottom by 1 plus cos theta. Now, once you've done that, let's multiply them together. Now, if you look at the numerator, 1 minus cos theta, 1 plus cos theta, that's a difference of 2 squares, which means you get 1 minus cos squared theta. Of course, you could expand out brackets if you wanted to. And the bottom is just theta 1 plus cos theta. So we haven't really done anything with the bottom as such. But we know our trigonometric identities. 1 minus cos squared theta is sine squared theta. And so we get this. What I'm going to do is split the fraction again into another product. And I'm just going to have sine theta over theta here. And then over here, I'm going to have the other sine theta. And I'm going to put that together with the 1 plus cos theta. Now, there are laws of limits which you can look up easily enough online. So what I'm about to do, without justification, can actually be justified. So the limit as theta tends to 0 of sine theta over theta times sine theta over 1 plus cos theta can be split into the limit as theta tends to 0 of sine theta over theta multiplied by the limit as theta tends to 0 of sine theta over 1 plus cos theta. As I say, I did that without justifying, but it is actually a fact. Now, once we're there, we've already established that this part is 1. So we know that this part here is equal to 1. Sine theta over theta. That was in the first part of this intro. If we look at this one, as theta tends to 0, sine theta tends to 0, but 1 plus cos theta tends to 2. So that means overall that this is going to tend to 0. So what we have here is essentially 1 times 0, which is 0. So what have we established here? This limit here, which we said would be important in differentiating from first principles, we've established that that limit is 0.